Integration by substitution. That should say substitution up there, sorry, not by parts. By substitution. So last time in the first lesson did 3 examples with you. Want to do some more examples now. This one is introducing trig for the first time and slightly adapted technique here as well. So trig can scare people. If you've got a formula book as well, it'll be really useful if you have the formula book page 5. Okay, I can put it on the screen as well, but if you've got a copy it will be useful. We here are looking at tan squared and sec squared, and if we can find any way of linking tan squared and sec squared together, or just secs and tans together, that would be useful. And if you look at this line here above the pen, that tells you that if you start off with sec squared and you integrate it, you get tan. So going backwards, that must mean if you start with tan and you differentiate it, you get sec squared. Okay? So I'm just going to write down here the information I have got from there is that if I start with tan, if I differentiate it, according to here, if I differentiate tan, I get sec squared. That's in the formula book. So I can actually write that. Sorry, it's gone off the screen. I can write that down straight away from this information that they gave me here. Now that's not the way we've done it before, but that's a really useful thing. You'll think because you already now have a u involved with sec squared and a u involved with tan. Because if I rearrange this line, well, I don't need to rearrange this line here actually. Look, I've got sec squared there, I've got tan there. If I go straight to rewriting that integral, what is tan squared going to be in terms of u?
U squared?
Yeah, if tan is u, tan squared is u squared. What is sec squared? Du dx. Oh, and I've still got that dx there. Mustn't forget to write it down. What can I do immediately at that point? Cancel the dx's. So my integral becomes just the integral of u squared du. What's the integral of u squared with respect to u?
U cubed over 3.
U cubed over 3 plus c, done the integral. Don't forget to put the plus c bit down. All we need to do now is change that u into whatever it is in terms of x. Well, u is tan x. So that answer becomes tan of x cubed over 3 plus c. Often, instead of writing the tan of x like that, you would put the tan cubed of x. Both of those lines are correct. The bottom line is a normal way of writing that down. Okay? So, that's something else, a slightly different technique there. If you can spot that when you differentiate the bit they've given you, it becomes actually something else that's really, really useful, go and do that. Okay? Now, if you look at the question here and look at the answer, there is another, actually, a red box rules thing, another shortcut you can take that works here. What we had here was this. Just need to zoom out a bit. We had an integral of a function. Tan x is some function of x. That function had a power on it. It was squared. So it had a power on it. And after the function, what is this? In terms of that function, what is this?
Differential.
The derivative, yes. The derivative of it. Yes, it's exactly what you said. I couldn't get the words out. It's that. So what we just had was that. A function with a power on it times by its own derivative being integrated. What did we end up with? Now, compare these. What do you think the right-hand side is? What do you think happens here? Remember, our function here was tan x. What happened in the answer bit?
It was just that integrate.
The function was there, but the power on it from a 2 to a 3 had gone up by 1, and we divided by the new power, and we put our plus c. And again, if you can remember that result, if you can remember that, it saves an awful lot of time. So the other one we had a minute ago was looking at any time you're integrating a fraction, is it its derivative over the function? Here, if you're integrating a product, is it a function times by its own derivative? And that power could even be 1. But if you've got a function times by its own derivative, you can go straight and quote that result, which saves an awful lot of time.
If you're doing an exam, would you have to kind of quote that rule to get the level marks? Or could you just do it?
You could just do it. You could just do it. It might actually help you if you did write it down and match it up. It might even help you if you were doing this in an exam, write that down, and then you actually said, and here, so my f of x is tan x, the power on it is 2, and the differential of it, the f dash of it, is sec squared x. And if you write that down as well, and then substitute in, it is actually, I think, less likely that you will make a mistake in answering the question. So the fifth example, okay, got this integration here, x times by the square root of 1 plus 2x all squared, sorry, 1 plus 2x squared. We're told what our u is. Joe, what's the first thing to do?
Find what x equals.
Yeah, so I know what this here is already, that's good. I need to know what x is. So if I move the 1, if I divide by 2, and if I then square root, and because I'm differentiating, it might be easier to write that as a power of a half. I know what x is. So that's just the rearranging side. When I know what x is, then what do I do?
Find dx to u?
Yes, I differentiate it. I'm going to leave a gap to put another line of working out in, but I am going to go next to dx du. Right, to differentiate this, that just looks a bit nasty. It might be easier to rewrite this as, that is u being divided by 2, or in other words, a half u. Then I'm taking away, that 1 is divided by 2, that's a half as well. And the whole thing is to the power of a half. Because I think that actually looks easier to work with, because you can do it, well, we'll see how we can do it. Can you, do you know how to differentiate a bracket like that? Okay.
Or you just differentiate what's inside,
Oh, yeah,
on the
yeah,
outside.
So yeah, what I'm saying is here, what we've got here is something like y equals ax plus b to the power of n, a bracket to a power, and when you differentiate it, what do you get then? This is another rule, a thing to learn. What do you get when you differentiate that?
A n. And then ax plus b in the bracket. Power n minus 1.
Yeah, that's right. The power comes down the front, the amount of x's comes down the front, the bracket stays the same, and you knock one off the power. Okay, so again, there's nothing new. You should have had that anyway. But once you rewrite the line I'm pointing to at the moment in a different way, once you rewrite that line like this line here, I think it then becomes easier because it looks like this. Your a is a half, and your b is minus a half. Your n is also a half. But if you use this red box rule here, what do? You write the a down. Well, the a is that half there. You write your n down, that's that power up there, and they're times together. You write your bracket down, and you knock one off the power. So that is what you get when you differentiate it. Now, that doesn't look very nice. It might actually be easier to try and rewrite it like we had it up here, to be honest. What are those two halves multiplied together? Quarter. This thing here actually is the same as that, because we just changed it to make it easier. So we could actually change that bracket back again. I'll put the minus a half on there, because it's less ink. Actually, it might be easier now to put it back like that. Now, you can leave it like that, or what does a minus power mean? 1 over. So you could, if you wanted to, just do the 1 over, just turn that upside down in there and deal with the minus power that way. 1 over is flipping a fraction upside down. So you could, if you want, get rid of that minus sign by flipping that upside down. And once we've got all of that stuff, it's a case of sticking it back into what we had. Integral was the integral of x. This was what x was here. U minus 1 over 2 to the power of a half. Then I had this 1 plus 2x squared square rooted. What will that be?
U to the power of half.
Good, yeah, it's that thing there, square rooted. It's u to the power of a half. Then I have dx. Well, dx is this line here with that du put there. Are you happy with that? So I will write that down, which is a quarter, the u minus 1 over 2 to the power of a minus a half du. Which looks disgusting at first. But, look at it. What can you do?
Pull out a quarter.
You can pull out a quarter, yeah, if you wanted, okay. That quarter there can go straight through the integral sign. It's just being multiplied by the whole thing, yeah. Look at the brackets. What can you say straight away about the brackets? The brackets are the same. You're timesing things together with powers on. What do you do when you times the same thing with powers on? What do you do with the powers? You add them. What do you get when you add a half and minus a half? So that bracket has a power of 0. Anything to the power of 0 is, effectively, they cancel each other out. That bracket goes with that bracket. The question has been designed at A level so that happens. So that it becomes something nice. Actually, what's actually left here? An integral sign, a u to the power of a half, and a du. The integral reduces to that at that stage.
Do you keep quarter or not?
Yes, thank you. I forgot to put my quarter at the front. I said I was going to do it, and I didn't. Thank you, Joe. Yes, you do. Okay. So, put my quarter down immediately before I forget it again. Integrate u to the half, add 1 to the power, divide by the new power, put plus c. Okay, I've got a triple-decker fraction, or whatever you want to call it here, a fraction on the bottom of a fraction. Dividing by 3 over 2 is the same as... Right, so that quarter is actually being times by 2 over 3. I've got my u to the power of 3 over 2 plus c. Okay, what's a quarter of 2/3? Times those fractions together. What will I get? 2/7. Timesing. 2
7. No.
2/12. Yeah, 2/12, which is the same as
1/6.
a 6. Okay. U, hang on, what is u? Right from the beginning of the question, u was 1 plus 2x squared square rooted. No, sorry, not square rooted. I'll write that line out again. It was 1 plus 2x squared. That's my u. I need to put the power of 3 over 2 on that and put my plus c down. That's a perfectly acceptable answer. However, the question didn't have powers, it had square root signs. So if you were looking in an answer book and you had that, it would be written slightly differently. The 1 plus 2x squared, that 2 on the bottom of that fraction means it is being square rooted. That 3 on the top means it is being powered 3'd. I'm not very grammatically correct, but I think you know what I mean. Put that in there. The 6, I could put it down there if I wanted, and my plus C. So what's underneath the orange line is possibly the answer you might find in the answer book. What's above the orange line is totally acceptable as an answer.